Join me and Charlie as we talk about how to test an RV's converter. Then, Charlie answers a frequently asked question about multimeters. Finally, join me while I dig a little deeper into something that is found in every RV.
Emily, you cannot do that to the elderly.
You know, I'm just trying to keep your heart healthy and young.
That'll do it. What are you up to?
Well, I was just having a conversation and a question popped up that I wanted to bring to your attention since you're working on all these electrical systems, and I figured you would be just the expert to ask.
What is that?
So the question is, how do I test my RV's converter?
Oh, that's easy. You know, I just built a brand new mock-up that explains the entire electrical system of an RV. Let's go take a look at it.
I would love to see that.
We are excited to announce the launch of our new Lippert Technical Institute YouTube channel. This channel's focus will be to inform a wider range of customers, ranging from technicians to owners, those living the RV lifestyle. We want to drive content to you that's impactful, comprehensive, and helps you get through some of those issues that may keep you from camping. Our previous channel will continue to be uploaded with content focused on warranty procedures and part replacement. To stay up to date with all the content the Lippert Technical Institute has to offer, be sure to subscribe to both channels.
So this is where the magic happens, huh?
Yeah, this is my project that I've been working on for a couple months, and it's an all-encompassing electrical system for an RV. It has its own shore power, it has its own battery, everything. It's completely standalone. But I wanted to focus on the AC power system on the left here. It has two systems inside it. And what that means is, like your smaller RVs, that they have a thing called an all-in-one. And that is a distribution panel and a converter all built into one, and that's what this one is here. But on the right side of this, we have a distribution panel and a converter. And this system you'll see on bigger RVs like fifth wheels and drivables Class A's.
Okay, so for like the smaller travel trailers, it's more condensed into one component, whereas for larger like fifth wheels or motor coaches, they're kind of divided into two different components.
Right, it's a power issue. By separating them, it creates the ability to make more power out of the converter, and it's also a space saver.
Awesome.
So what I want to do is I want to walk through the differences between them and what that means to us when we check it. So the system or the process to check both are pretty identical, but you're testing in different spots.
Okay.
So let me go ahead and take these covers off, and then I'll show you what I'm talking about. Starting with the all-in-one, we have, like I said, it has the converter built inside it, which means it's transferring that AC power to DC power. So let's follow the wiring so you have an idea of how this all works together. So this junction box here is the back side of the shore power. So the 120 volts AC comes from the outside, comes into this junction box, and you see that line going up to the distribution panel, but you also have one that goes right into the all-in-one.
Okay, so you have these two completely separated with their own 120 volts.
Correct, yeah. So I have two systems so I can teach the smaller RVs and the larger ones. Focusing on the all-in-one, that 120 volts AC comes from the junction box and goes right into the all-in-one. So if you're testing the converter inside the all-in-one, you have to make sure, step one, that it's receiving power. So you can take a multimeter and make sure that that 120 volts AC is there.
So for the people that don't know and have never really tested their converter and all-in-one power centers, where would they place their probes of their multimeter to check for that 120 volt AC current?
Awesome question. Let me show you with a multimeter. So you're going to set your multimeter on voltage and then change the select button. All multimeters are different, but for this one, you're going to press that button and make sure that that says AC. So your first step will be to take the positive probe and put it on the power lead from your 120 volts AC coming in on this orange wire, and that goes to this 30 amp circuit breaker. So I'll place that on that lead there, and then I'll find the ground bar that the negative is going to and place that on there, and you'll see 123 volts AC. Now that we have the 120 volts AC that is powering, and we know that it's getting to the all-in-one, now for the next step, we're going to verify that the converter works inside the all-in-one.
Okay.
And we're going to do that by testing the output of the converter for that 12 volts DC, and this is going to go to the battery. So we're going to just keep going down, isolating different sub pieces and parts in the system. So I'm going to take this circuit breaker and turn it on. This turns on the converter inside the all-in-one, and that's what's going to transfer that 12 volts DC. So now that I have that on, I'm going to make sure that my multimeter is set to DC, and then select this red and white wire. Here's your output of the converter, and this is what's going to charge your battery. So why don't you go ahead and turn off the 12 volts from the battery, and that's going to just completely isolate the 12 volts coming from the converter. So if you could turn that off. Now the battery's completely out of the system, so we know this 12 volts is being converted. And we have 13.4 volts DC, and that's good to go. So now that we know that the 12 volts is coming out of the converter, we know this module works, right?
So Charlie, you had us isolate the battery for this testing. Are there any other connections or components that could have an effect on our measurements and testing readings?
Actually, there is, and I'm glad you asked that, because you know, and we talked about, the battery is connected to the ground, the chassis. There's a wire that goes to the chassis, and that is on this bar right here. And what I did is I screwed this directly to the frame of the RV, and as you know, RVs can bounce around and vibrate quite a bit. And if this bar gets loose and it doesn't have a good connection to ground, then the battery won't be grounded, and you'll have DC electrical problems in the RV, like flashing lights and stuff like that. So that's a really, really good point, and I'm glad you asked that. Recreational vehicles have hundreds of electrical contacts, components, and circuits. Knowing how to use a multimeter and troubleshoot electrical issues is a great skill set. So you may be wondering, well, how do you use a multimeter, or where do I check the wiring? There's a lot to know and a lot to learn. So I'm going to show you not only how to use a multimeter, but how to use it on an actual RV using 4 basic electrical checks commonly used on RVs. Here I have a common digital multimeter. It happens to be the one that I use, but it has 4 areas that are universal on all digital multimeters. So the first one here is the selector dial. This one you can move back and forth to ohms, volts, amps, that type of thing. Up here we have a function button. It says select there. That'll allow you to change from AC current to DC current. You have your red and black leads. One's positive, red, black is negative. And then you have your digital display screen here that shows you the results of the test that you're taking. Now let's take a look at the 4 common tests that you will perform on an RV. And that is, first one is component power testing. What you're doing there is you're looking at the power that runs that component. If the power is there, then you eliminate the electrical portion of it, and you start focusing on the component. Then you have wire testing, individual wires. You're checking for continuity and making sure that that individual wire is good to go. Then we're going to look at shore power testing. Now that also includes testing on the 12-volt circuit as well. We all know that RVs have two electrical systems, one that's DC direct current and one that's AC alternating current. One has 120 volts AC, one has 12 volts DC. We need to make sure that the RV is being provided that power to run all the components and appliances. And then the last one is connection and circuit testing. We checked wiring here, but if you start adding in mini breakers and quick disconnects, you create an actual circuit, and that's what we can test, and that tests the wiring and the components in the wiring. Now let's go out to my RV, perform these tests, and I'll show you how to perform the test and what the results will be. Here we have a replica of what a shore power terminal looks like. This is a 30 amp, 120 volt receptacle, just like you'd find at a campsite. So I'm going to make this real simple and check one area for that 120 volts AC. So I will take the positive lead and put it in this left terminal, and the negative lead in the right lower terminal. Now that those are in there making contact, I'm going to take my selector dial and put it on volts. Make sure it's on AC, and you'll see 121 volts AC. For this next test, we're going to do a component check, which is making sure that we have DC voltage out of the battery and that it's within spec. So let's go ahead and move the dial to voltage and make sure, utilizing this selector button, that it's DC voltage. And then we'll put the red lead on the positive and the black lead on the negative. We should get 12.6, and we do. We have 12.61 volts DC. For the next couple tests, I'm going to make the multimeter read ohms, which is resistance, which is connectivity, making sure that the wiring that you're checking has complete connectivity from point A to point B. So let's change this dial to ohms, and you'll see 0 and an L there. And for the first test, I'm going to check the continuity in this short red wire here by putting one of the leads here and one of them on here, and it reads 0.0 ohms, which is perfect connectivity from point A to point B. The next test, I'm going to check the components in a circuit. So I'm not only going to check this wire, but I'm going to check the mini breaker all the way up to the quick disconnect. So this small circuit. So I put one of the leads on one side and then one on this side, and I'm checking connectivity through the mini breaker and the wiring that's included in that circuit. For this test, we're going to perform a components test, and that is making sure that the power supplied to the refrigerator is there and enough to operate the refrigerator properly. So what I've done is I've removed the refrigerator, and I also disconnected the power wire from the refrigerator power wire so we can just test the incoming power. So we have a black wire and a white wire. This is going to be your positive and this is going to be your negative. So let's move the selector switch up to voltage, make sure that it's on DC, and we will take our red probe and put it on the black wire, and the white wire will have the black probe, and we should get around 13 volts DC. So we know that the refrigerator is receiving the power it needs to properly run. If you enjoy the content so far, please subscribe to the Lippert Technical channel to keep up to date with our latest videos.
Charlie, it's the Lippert Technical Institute channel.
What did I say?
this all-in-one is for the smaller travel trailers, but like what about the larger trailers like fifth wheels or motor coaches? Is it a different system?
Yeah, actually, sure. Let's take a look at that. Now remember that the bigger RVs actually have the distribution panel and the converter separated. It's not all in one little system, right? So we're going to go ahead and turn the old one off that we had powered earlier and turn the new one on with the main breaker, and this outlet here is this circuit breaker. So now the bigger RV system is on. So remember before we were checking the power that comes in. So coming from shore power, you follow that orange wire up, that's your 120 volts AC, and we need to make sure that that power is there, right? So can you hold that for me?
Absolutely.
Make sure that your meter is set to AC voltage, and we're testing this main breaker with the 120 volts AC. We'll take our power lead to the power wire and put it on ground, and we should have 120 volts AC, and we do. So we're good. So we know that it's receiving that power, and we're eliminating it as we go, just like we did before. So now we're looking at these two wires going into the distribution panel, and we see that the power lead's coming in here and the negative lead is here, and we should have that 13.5 roughly volts coming out of the converter, and we do. So we now know that the converter is supplying the distribution panel with the proper voltage to charge that battery.
So Charlie, you've mentioned a few times that you're looking for 12 volts, but we're actually reading 13.4 volts at both of our converter points and our battery. So is it common that we're so much over the voltage for 12 volts, or are we looking for a 12 volt signal?
Yeah, that can be confusing, but in the industry, a 12 volt circuit is commonly referred to as 12 volts. However, your converter supplies between 13 and 14.2 volts to the distribution panel and the battery, and that's that range that you're looking for. So I will refer to it as 12 volts, but for the converter, it's gonna supply like 13.5 volts.
Okay, so it's more like 12 volt is the kind of system we're working on. What happens if we're outside of those measurements?
So if it's too high, it's supplying too much voltage and it can cause damage to the battery. And if it's low voltage, you can just guess. Your guess is as good as mine. Weird things can happen. Low voltage is a common problem in RVs, and it starts with the battery, but this will help troubleshoot that and make sure we know what the actual problem is.
You've shown us quite a few different places to take measurements and what those measurements should look like if the converter is good. But what if somebody finds that they're not getting those same measurements? Does that mean just the converter is bad?
Yeah, that's a really good question and point. Well, it could be, but what you're going to look for here is that 12 volts, and if it's not there, then you're going to walk it back all the way to the converter, and you're going to check the wiring here at the contacts on the converter. That eliminates this wiring and this contact. Then you're going to move that a little bit further into the power that runs the converter. So this is 120 volts AC, 20 amp. It's fed by this distribution panel, and you can see this yellow wire that feeds it, and this is your circuit breaker. So making sure that testing at the circuit breaker all the way to the wire, you pull that plug out and check for 120 volts AC here. So one of those four things, including the fuses on the converter. So there's a series of fuses depending upon what converter you have on here that you're going to check. You can pull those out, take a look at them, and make sure that those are working. So those 4 points: the wiring, the contacts, the power into the converter, and the fuses. Once you check all of those, if you're not getting 12 volts DC here, it's going to be one of those things. And if it's not, then the converter's bad.
Well, Charlie, I really appreciate you running me through how to test a converter, and it's kind of inspired me to go work on my own project. Do you want to tag along and help out?
Yeah, that sounds great. Let's go.
Let's go. First things first, what do we mean by low voltage? In the world of RVs, low voltage refers to your electrical system receiving less than the needed power, which for most RVs is around 120 volts AC from a shore power connection or generator and around 12.8 volts DC from a battery. When voltage drops below a certain amount of voltage, appliances start to run into issues. Your air conditioner might struggle, your refrigerator may not cool efficiently, and other electronic devices could suffer damage over time. And that's just for your alternating current side or 120 side. The same concept applies to when your battery voltage drops below 12.3 volts DC, but your low voltage components like lights, motors, and fans will be affected. How do you spot low voltage? Well, one essential tool you can use is a multimeter. With a multimeter, you can check your power supply either coming from your shore power or from your battery bank. By checking the voltage supply at your RV's power source, you can monitor if the voltage consistently falls below the ideal range. This range is normally plus or minus 5% of the optimal voltage. Multimeters are easy to use and are a great tool to help keep an eye on voltage readings, especially during peak times when the demand on the campground's power is at its highest. You can also use a high-precision battery monitor to track if your battery is falling below that 50% charge, which is considered low voltage for your DC side of your system. So what causes low voltage? Often it's due to an overloaded campground power grid or a problem with your RV's electrical wiring. High demand in peak season can also contribute when everyone is drawing power at once. If you find yourself facing low voltage issues, there's a couple of fixes. You can reduce your own power usage, preventing that low amperage from affecting your components, or you can invest in a voltage regulator or a surge protector, which helps manage the voltage levels entering your RV. These gadgets can not only protect against surges, but also help maintain steady voltage levels. Understanding and managing low voltage is the key to protecting all RV components and helps ensure a hassle-free adventure on the road.
Dive into our collection of updates and information at the Technical Institute Insider Playlist. Right now, we have another exclusive behind-the-scenes installment, this time with our Technical Publications Department. You can also catch up on our latest video and document releases. Don't miss out. Explore the Technical Institute Insider Playlist today.
Well, Charlie, that electrical mock-up you made really came in handy.
Well, that's exactly what I built it for, and I'm glad I was finally able to show you.
Well, and I'm glad we had the opportunity to use it, and I promise I'll probably stop scaring you.
No, you won't.
Probably not. But to all our viewers, we appreciate you tuning into this episode of the Technical Institute Show.
Be sure to catch our next episode where we'll dive into the world of solar power.
Plus, we will also be addressing another frequently asked question from you.
Don't miss out. Subscribe to the Lippert Technical Institute channel to stay updated on the latest releases and exclusive content from Lippert.